Hello, friends. Welcome to Science Talk. I'm your host, Jim Massa. Fresh water is pouring into the Arctic Ocean. Climate change is to blame, new study says. The effects of the changes may already be in motion, researchers says. Okay, so this is a story that came out about a month or so ago. And we're looking at a photo taken August 16th from last year. And large icebergs float away as the sun rises near Kulusuk in Greenland. A new study suggests human-caused climate change is what's driving the increased amounts of fresh water into the Arctic Ocean. Well, duh. Between the melting of the ice sheets off Greenland, as well as alpine glaciers, and of course, what's going on in Antarctica, yes, there's a lot of fresh water pouring into Antarctica, and it's because the planet is warming, and the planet's warming at a very fast rate due to continual combustion of fossil fuels, releasing CO2 and water vapor into the atmosphere. The Arctic Ocean is not as salty. The salinity is decreasing as it used to be. And yeah, this is most likely due to climate change. Well, it is due to climate change. I'm going to bluntly state it. It's due to climate change. Right? You add all that fresh water in, you add this freshwater lens, as we say, on the surface, you decrease the salinity. Previous research pointed to natural cycles as the cause for unexplained influx of fresh water. Yes, that has happened before in the past, but again, like everything else, it's the rate of change. And we're now seeing what's going on with all the heat trapping, CO2, methane, N2O, H2O as well, that is accelerating the melting of the ice and dumping all that fresh water into the ocean. And that will, of course, have the effect of slowing down AMOC, slows down the conveyor belt, slows down the Gulf Stream. New study published in Geophysical Research Letters suggests human-caused climate change is driving increased amounts of fresh water in the Arctic Ocean. It's another worrying sign in that we've already starting to see clear changes from climate change, Alexander Yan, lead author of the study, said. He is an assistant professor in the Department of Atmospheric Oceanic Sciences and the Institute of Arctic Alpine Research at the University of Colorado Boulder. And the Arctic Ocean is connected to the rest of the world, can have cascading effects. In the study, the researchers examined the results of multiple simulations run from 1920 to 2100. Dr. Yan says when the simulations all do the same thing, that's due to a forced response. In other words, it's a clear climate change signal. Researchers also ran simulations of different emission scenarios from business as usual, which will result in global warming of over 4C, some say 9C, to the reduced emission target that would result in closer to 2C overall. But the effects from the freshening Arctic waters are already in motion. That means those emission reductions might not make an immediate difference, even if they will reduce the amount of fresh water in the second half of the century. Because you're already changing the physical characteristics of the oceans. Now, remember, the conveyor belt is a heat distribution mechanism for the planet. The Gulf Stream brings warm water up into the subpolar region, gives off its heat, which keeps the UK and Scandinavia warm. It cools down, it's salty, it sinks, and have a return flow. If you slow down that conveyor belt or stop it altogether, the Gulf Stream will slow and or stop. You don't have that heat coming back up to that region. Those regions start to cool down. So this will have an immediate effect. So we're warming the planet, but we could also cool down certain regions as well. And if that conveyor belt stops altogether, models, especially by the late Wally Broker, indicate ice ages ensues. Now, I've been arguing that climate change will bring this on. Now, the global warming will eventually bring on an ice age. But with considering all the thermal inertia, all the thermal energy already in the system, this is not going to probably happen for Minimum 500 years, most likely a good millennia or more. But still, things are in motion. So here we have a photo of a Canadian Coast Guard sailing between icebergs near Makkovik, Labrador. Now, freshwater in the Arctic Ocean isn't necessarily bad or even uncommon, but could have destabilizing effects as it flows into other oceans. Well, if it stays in the surface water, you will get some stratification, so you could get some productivity if there are phytoplankton that can do well in the reduced salinity. There's already been a 10% increase in freshwater in the Arctic Ocean, which is about 2,400 cubic miles. That's the equivalent to the amount it would take to cover the entire U.S. with 3 feet of water. So think about that. Now, that's referring to the continental U.S., the lower 48, does not include Alaska and Hawaii. The same stabilizing mechanism makes the Arctic Ocean unique, could have disruptive effects other places as the fresh water leaves the Arctic. What happens in the Arctic doesn't stay in the Arctic. You've heard me make that statement numerous times before. More fresh water could cause changes in ocean currents in the North Atlantic, the currents that help keep winter temperatures in northern Europe more mild. This goes back to what I just described about AMOC, the Gulf Stream, and so on. This change might be felt within the next decade, if not already. Those colder winter temperatures would actually mitigate the impacts of global warming in northern Europe for a while. But long-term disrupted ocean current could have negative effects on climate and on the North Atlantic ecosystem. Now, this is an interesting photo. Icebergs off the west coast of Greenland. This is the Nares Strait between Greenland and Canada is likely to be the first place to see a freshwater export increase attributable to climate change in the next decade. And then changes in oceanic circulation might be seen in the rest of the world. Ocean straits farther south and east, including the Davis and Fram Straits, will be next to show this signal in addition to the Nares Strait. We hear a lot about changes in the Arctic with respect to temperatures, how ecosystems and animals are going to be affected, said Rory Leho, a co-author, and he's a PhD doctoral student in atmospheric oceanic science. But this particular study gives an added perspective of what's happening physically to the ocean itself, which can then have important implications for ocean circulation and climate. For those of you who followed my channel for some time, you know I have been discussing all these things for quite a few of my videos. So nothing new from me that you know, but it's good to see others starting to make this realization and to start actually looking at this in more detail and seeing more studies addressing this issue. I've been saying this for some time. It's good to see this kind of research being done. So anyway, nothing really spectacularly new information. We all know that fresh water is pouring into the Arctic Ocean, but I'm doing this video segment so to basically give a shout out for those researchers now looking at how it's going to impact what the oceans do. You've heard me describe how the slowing Gulf Stream will affect Northern Europe. They're now looking at that, and that's basically what they were saying here. So, wanted to bring this to you. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.